In this video, we're going to explore the use of AQUARIUS' empirical modeling toolboxes in the context of doing some data correction. Now, in advance of this video, I've loaded in some data here. We've got some ADFM data, or acoustic Doppler flume meter, and some flume readings for two stations, S1 and S2. You can see here if I hover over, I've got some data for Site 1, the ADFM. I've also got the Site 1 flume data here. And I've also got Site 2, which is a little bit further downstream, and I've got an ADFM meter for that specific site. So what I want to do to begin with is let's just have a look at this data. I'm going to go down to Visualization and Reporting, and we're going to grab a quick view box. Now we want to look at three things at once, so I'm going to right-click here and go to the Properties pane, and we're going to change the number of input ports on this to 3, so we'll be able to plot three things at once. I'm going to drag these across and just wire up my data to the 3 ports of the Quick View toolbox. If I bring that out a little bit, we'll double click on that one in order to run it, and we'll get the graph of all 3 of our data sets. Now if I lock all of my axes together here, we can see that if we zoom in on certain sections of the data, we can really highlight some of the errors that we're going to try and correct. The first one that pops out to the eye is this one right here. And if we look at that section of data, we can see we've got a flat line in the Site 1 ADFM. And what we have in the Site 1 flume is complete data. So what we're going to try and do is build a model between these two sites near this period in time in this record, and then we're going to do an estimate of what the data is right here. The other thing we're going to be able to do is use this section of record for an example of inter-site relationships. So you can see here my ADFM at Site 2 and my ADFM at Site 1 have corresponding sections where I have an overlap of bad data and good data. Now I'm not going to be able to use the Site 1 flume and the Site 1 ADFM to do a relationship here because I have a flat line in both of those signals. That's probably due to a communication error. So let's back out of the Quick View toolbox and actually start up the empirical modeling toolbox in the context of data correction, and that's the model-based correction toolbox. I'm going to drag that one out onto the whiteboard, and you'll notice here we've got one target signal, so I'm going to wire that one up to the ADFM for Site 1. And I've got a surrogate port here, but I'm actually going to want to work with 2 surrogate ports. So I'm going to again go to the Properties pane and change the number of input ports I have here to 2, so that once again on the model-based correction toolbox I now have 2 surrogate panes. So if I wire in both of my surrogate time series, I'm just going to do that by dragging from the input ports and splicing onto the wires that I already have on the whiteboard. I can double click on the model-based correction toolbox to start up. And in a second that toolbox is going to start, and I'm just going to maximize it so as everything gives us the most view we can here. And so right now if we go to the modeling tab right down here, we'll see that both of our surrogate time series have been loaded as surrogate time series for the modeling. Now this would be okay if we wanted to do a multiple regression model, but we actually only want to use one at a time. So I actually want to first off delete Site 2 as a surrogate because we only want to use Site 1 when we're going to do the model-based correction here. So we're going Site 1 flume to Site 1 ADFM. If we just zoom in on that section of time series right there, we're going to be able to go in and actually build a model that characterizes the relationship between these two. Now in theory the ADFM and the flume should be reading exactly the same thing, so we'd expect a complete one-to-one relationship. And we'll be able to characterize that pretty easily if we delimit a section of data here as training data. I'm going to add training markers. You can move these markers just by right-clicking to change the marker that's active, and when the marker is active, just a normal left click moves it around. Once we've delimited the data we want to use to build the model, I'm going to click to build or test a model, and it's going to bring up a plot of the subsection of the data. You can see here's the data that we selected for training on the model. We also see a scatter plot of one parameter versus the other. Now you can see here there's a very good relationship in between what the flume and the ADFM are reading in this particular case, and that indicates that the flume is well calibrated. So what I'm going to do is add a linear regression model between these two sites. And if I add that as a model, we're going to get the linear regression parameters model. We have the title of the model, so I could call this the LR flume to ADFM model. And I can also add additional model comments if I want to. We also have a validation factor down here at the bottom. Now this is a percentage of data that's kept independent when we're actually calculating those regression coefficients. So we're going to be able to test the model on data that the model hasn't seen before. And this will give us a good idea of whether the model is useful for predicting data on sections of time series it hasn't seen. If I click to add that model, we're going to see a pink line, which is what the model actually produces over the training data set. And we're also going to see a residual in between the two. So this is the difference between what the model is predicting and what the sensor is actually reading. We're also going to get a straight line going through our scatter plot, which is actually going to represent our response surface of the model. So that's a fairly good model. So we're actually going to go and use that to do an estimate of the data. And to do that, we need to go into the Model-Based Correction tab, and we need to mark a region for correction. So we'll click the Add Region button, and again we get these markers. And if I right-click just to change the marker that I want to move, and then move the markers to delimit that particular gap right there, I can click to fill that region. And when I fill that region, it's going to fill it with the active model. So the active model status, I only have one model in this case, and it's the Flume to ADFM model. We're going to invoke the Correction History Manager as well, which is going to read my Windows username, and it's going to go and add a comment here about what particular model I'm using, what the error on that model is, what the name of the model and the training data, all those sorts of things are included in that comment. I can add additional comments if I want to here, and that'll go into the Correction History Manager. If I click Apply, we can see right there I've got an estimate of what my model is. If I choose to show the raw data, you can see in blue, of course, there's the original data, but once again, we've gone in and we've done an estimate over those 4 days of missing data. So that's an example of using a relationship in between two sensors using two different technologies, acoustic Doppler, and in a sense a level transducer and a flume, to calculate an estimate of what the data is when we have two sensors both recording at the same site. I'm just going to clean my markers off here. Now the next example of what we want to do is actually when we have failures of communication at specific sites. So if I look here, we're not going to be able to do this type of thing in this case because we have a failure in communication for both of the sensors at site 1. So what we're going to need to do is use a different surrogate. So if I delete that surrogate, and in this case bring on the surrogate for the ADFM at site 2 and add that one as a surrogate data set, we can see here that we've got a relationship between the two. Once again, there's going to be a good relationship in between these two sites. But during the period of record where I have a communication failure on the site 1 ADFM, I'm going to be able to go in and do an estimate of that data because I do have good data from the site 2 ADFM. So once again, if I go back to the Modeling tab, I can create a training section of data just with these green markers. And if I move these across, I'm going to select a few days, about a week's worth of data here. And again, I'm going to build or test a model on that section. Once again, it's going to bring back, it's actually including the model that I had before. Now this is probably not a useful model in this case because it only represents the relationship in between the two sensors at the same site. We're going to see that section of data for the training data that we've specified. We're also going to see the scatter plot. Now one of the things you're going to notice in the scatter plot here is a great deal of hysteresis, and that's because there's travel time in between these two sensors. And that's why we provide tools down here for doing phase adjustment, or essentially sliding forwards in time and backwards in times, two time series, one against another one. And you can see here as I adjust the phase here, forwards and backwards, and we've got a maximum range here in hours that you can adjust as well. You can see those time series moving out of phase and the peaks eventually completely misalign. Now this moves forwards and backwards in steps of points of your time series. This is a 10-minute data set, so I can move fairly finely, and you can see here as I adjust this time series in and out of phase how those figures change. I can even auto phase adjust, and that will find the maximum linear correlation in between these two sites. And it looks as though we've got about a third of an hour, maybe about 40 minutes in between these two in terms of travel time. So what I'm going to do again is put a linear regression model through there. And if I add that as a specific model, once again we can give that a title if we want to. I could call this LR Site 2 to Site 1 Flume data. Or actually this is ADFM data. And once again we've got a validation factor that we can keep usually at 20% is a good number to keep as independent data. As we go through we can see what the model predicts versus what the sensor is actually measuring. And we can see it's a linear regression model. Now these training error and test error numbers down at the bottom are also useful measures of how well our model is performing. These are the mean absolute error numbers. In the case of the training error, that would be for the first 80% of the data, because remember we use 20% of the data for calculation of the test error. And this is a good indication, if these numbers are close to each other, of what the model will do on data that it hasn't seen before. And again, these numbers are mean absolute errors, so it's in the units of what we're doing of our time series. So this would be million liters per day in this particular case. So if I click Done, once again, we can actually go and use that model now. If I go to Model-Based Correction and I delimit a region, I specify that region where we have the flat line and the one sensor. I can go in and do an estimate of what that data is by filling that region. Again, with the active model, this is the linear regression from Site 2 to Site 1 ADFM data. And if I fill that region, once again, it's going to invoke the Correction History Manager, and it's going to read my Windows username. The auto comment is going to be different this time because, of course, I'm using a different model. And if I click Apply, once again, we're going to see the estimated data and the raw data right there showing up as blue. So we can of course save this to the output port, and now we have a corrected time series here. And if you look at the bottom of the tooltip there, the correction items are 2. So we have corrected data here, and of course we could pass this off to various other toolboxes on the whiteboard to work on it. But that's essentially what we wanted to do in this process, is go through and do a couple of model-based corrections. One for inter-site relationships, and one for 2 different sensors using different technologies at the same site. And that concludes how we can use the empirical modeling toolbox in the context of model-based correction.